In this example, we will be conducting a one-sample t-test on a population mean. So here's our context. A company claimed to have developed a new AAA battery that lasts longer than its regular AAA batteries. Based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. An SRS of 15 new batteries lasted an average of 33.9 hours with a standard deviation of 9.8 hours. Do these data give convincing evidence that the new batteries last longer on average? All right, so the first thing that I want to do is list out the provided information from the context. All right, so we've got a few different numbers here. We've got this 30 hours number, 33.9 hours, 9.8 hours, SRS of 15. All right, so the 30 hours will actually end up being our null hypothesis. All right, so the null hypothesis will be mu equals 30. Right, the alternative hypothesis will be that mu is greater than 30, because we're claiming, or the manufacturer is claiming, that the new batteries will last longer than the previous batteries. Right, the previous batteries lasted for 30 hours on average, so the alternative is that we're going to last longer or greater than 30 hours. Right, we have a sample size of 15 and equals 15. Right, the sample average, x bar, was 33.9, and the sample standard deviation, s sub x, was 9.8. Right, this is all the information we have. The only other thing we have that we'll need to conduct this inference method is a significance level, which we weren't provided. Since it wasn't provided, we'll just use 0.05 for our alpha. And that's kind of like a good little default if we're not provided one. The common significance levels will be 0.01, 0.05, and 0.10. All right, we're just going to use the 0.05 for this case. All right, so now we're ready to start the four-step process and conduct our one-sample t-test on mu. So we'll start with the state step. Right, so our statement is we want to test the hypotheses h naught such that mu equals 30 hours versus the alternative hypothesis h sub a such that mu is greater than 30 hours at the alpha equals 0.05 significance level, where mu represents the true mean battery life of the new AAA batteries. Awesome. All right, so now we'll move on to the next part. Planning. All right, the random condition is met because the sample was an SRS. All right, our 10% condition is satisfied because it's fair to assume that 15 batteries is less than 10% of all the batteries manufactured. And lastly, our normal large sample condition is kind of met in a roundabout way. Essentially, based on the information given, we can assume that the distribution of the sample is normal because we're provided the mean and standard deviation. We don't really have any other data to go off of. We don't have the individual samples. So we can't really construct the graph. So we're going to assume that the sample distribution is approximately normal based on the given information. And now we're done with the planning part. We'll move on to doing our calculations. Oops. All right, for this, we need to calculate the t-statistic. And that is t equals x bar minus mu naught divided by sample standard deviation of x divided by the square root of n. Sample size. So, using all the values we have, we have 33.9 minus 30 divided by 9.8 divided by the square root of 15. We put that all through the calculator and we get approximately 1.54. Right? This is our t statistic. Right? We now use this to find the p-value. Now to do this, we need to use table B. Right, so let's get table B in here. Alright, so we have our copy of table B. And first, we need to know the degrees of freedom. Right, our sample size was 15. So we have degrees of freedom 15 minus 1, which equals 14. Right? We can actually find 14 on our table here. Right? And we need to follow this across till we get to 1.54. Right? And that happens right between the 1.345 and the 1.761. Right? It's going to be in the middle. Right? And this happens when we typically do a one sample t-test. We'll get between a couple of p-values. And that's totally okay. We just get a range. We can say, okay, well, it's between these two values. All right? So in this case, the p-value is actually between 0.05 and 0.10. Now it's definitely going to be greater than 0.05 and definitely less than 0.10. Right? So we can safely say at this point that it is greater than 0.05, which was our significance level. All right. So then we can conclude. So, because the p-value is greater than alpha equals 0.05, we failed to reject the null hypothesis. We do not have convincing evidence that the new batteries last longer than the regular batteries. And we've completed our one sample t-test on a population mean.